Alright, so now let's delve into similar polygons. So in this lesson, you're going to learn how to find a scale factor between two polygons, write similarity statements, as well as find an unknown variable using your knowledge of similar polygons. Alright, so just to do an overview of similar polygons, what exactly are similar polygons? Well, there are polygons with the same shape but a different size. And polygons are similar if their corresponding angles are congruent. Also, if their corresponding sides are proportional. And if the polygons are similar, their perimeters are also proportional as well. And the ratio of corresponding sides is called the scale factor. So an overview of similar polygons, and so let's go ahead and get into the lesson. So how do we determine if the scale factors are proportional? Well, there are two ways you can do that. The first way is to reduce each ratio or each fraction to the lowest form. If the reduced fractions are the same, then the ratios are proportional. And we have an example right here. If you have two ratios of 6 over 20 and 18 over 60, if you reduce those two fractions, they both reduce to 3/10. So since it reduces to the same or simplifies to the same fraction, those ratios are in fact proportional. So that is one way that you can determine proportionality. Another way is to multiply each denominator by the opposite numerator. This is also known as cross multiplication. And if the products are equal, the ratios are proportional. So you can cross multiply. So we have an example here of the same ratios. If we cross multiply, we get 360 for each side or for each answer. And so this tells us that the ratios are also proportional as well. Alright, so let's take a look at actually finding the scale factor. So now exactly what is the scale factor of these two triangles? Triangle ABC and DEF. So we can just take one pair of sides, and so we can see here that we have AB right here. We have one arc and two arcs for B, so we want to look for that on the same side for the larger triangle. So we have one arc here and two arcs, and so these would be the corresponding sides. So sides AB and DE. And we could just write that ratio as 8 over 12 and just reduce the fraction there. So they're both divisible by 4. And so that fraction reduces to 2/3. And so the scale factor for triangle ABC to DEF is 2/3. Now, what about this one here? It says, what is the scale factor of DEF to ABC? Well, the order does matter. So we can see here that triangle DEF is stated first. And so that ratio, or the length of that side, will be actually in the numerator of our fraction. And so we could do 12 over 8, and that reduces to 3 over 2. So that is the scale factor of triangle DEF to ABC. And we can also write the ratios this way, 3 to 2, 2 to 3 up here. And also just to show you, if we use another side here, if we choose side BC, so it has 2 arcs here and 3 arcs here, 2 arcs here and 3 arcs here. So these sides are proportional, or they're corresponding. 10 over 15, that in fact reduces to 2/3. So same scale factor. All right. So keep in mind that order does matter, but you're simply taking the corresponding sides and reducing that fraction. Now for this one, it asks what is the ratio of the perimeter of triangle DEF to triangle ABC. So the perimeter for the first one here, that's going to be 8 plus 10 plus 14, and that will give me 24, 32. All right. And then 12 plus 15 plus 21. So let me get my calculator right quick. So I feel like adding that manually. plus 15 plus 21. That is 48. All right. So rate the perimeter for the top here, or the smaller triangle, is 32. Bottom is 48. Let's just write this as a fraction, and I'm actually making a mistake. I'm putting the 32 first. So my mistake is, it says from triangle DEF to ABC. So we want to write the 48 first. So 48 over 32. They're both divisible by 16. So 48 divided by 16 is 3. And 32 divided by 16 is 2. So as you can see here, we have the same ratio. All right. So that is how you find the scale factor of similar polygons. Let's take a look at writing similarity statements. And a valid similarity statement must match corresponding angles and sides, meaning they have to be in the same position. All right. The symbol for similar is just a squiggly line like this. You could kind of say it's the top of a congruent sign. So this is a congruent sign right here, right? So that little squiggly line that we put at the top of a congruent symbol, that is the symbol for similar. All right. So a valid similarity statement for these two triangles would be triangle ABC is similar to triangle DEF. And notice, oh, that's an ugly E. Let me fix that a little better. All right, so notice that A and D, same position, they're both first. They both have one arc. They are congruent. B and E, same thing, two arcs, and so they're both congruent. All right, so C and F, the same thing. Also, if you look at, let's look at AB and D, side DE. AB is here, right? DE is here. They both have that one arc and two arc between them with the congruent or the equal angles. So those are corresponding sides, and their ratios are proportional, as we discussed in the previous slide. So valid similarity statement, just remember that the corresponding angles and sides have to match, or they have to be in the same position. So now we want to list all congruent angles and write a proportion that relates to the corresponding sides. In example 1 here, we have triangle JKL is similar to triangle PMN. So it's telling us that they are similar. So the congruent angles would be angle J is congruent to angle P. Angle K is congruent to angle M. And I'm just looking at the positions here, right? And so next we have L and M in the same position. And so angle L is congruent to angle N. So we can tell that by the similarity statement. I'm not looking at the triangle. You need to look at the similarity statement to see what angles are congruent. And so the proportional sides would be, so looking at my similarity statement, JK and PM. So a proportion would be JK over PM is equal to, we could say JL and PN, both in the same position, first and last. So JL and PN. So write that as a fraction or a ratio. So JL over PN, as well as what is left. Last, let me use a different color. We have KL and MN. So KL and MN. So we've written a proportion to match those corresponding sides, and we've matched the congruent angles as well. All right, so for example 2, we have a triangle within a triangle. We have a smaller triangle within a larger triangle. But again, if you just look at the similarity statement, you can write your congruent angles and your proportional sides. So X is congruent to R. All right. angle Y is congruent to angle Y. So same letter in the same position, they both share this angle right here. And then angle Z is congruent to angle S. So they both last. All right, so now let's look at our proportional sides. The larger triangle XY, that side that is in the same position is the smaller side here on this smaller angle. That would be RY. And then we could do XZ right here to RS. And then, so they're both in the same position here. And then YZ, the only one that is left on this side. So YZ and YS. All right. So now next you're going to try one on your own. All right, so I would like for you to try example 3. List all congruent angles and a proportion that relates to the corresponding side. So go ahead and pause the video and try this one on your own. So here are the answers for this problem. So you just had to look at the similarity statement to see the congruent angles and look at the corresponding sides to set up your proportion. So check your answers and hopefully you got them correct. In this example here, we want to determine similarity. So it asks, are the polygons similar? And if they are, we want to write a similarity statement and give the scale factor. So the first thing we want to do is identify pairs of congruent angles. So we're just simply looking at the arcs. So angle A is congruent to angle D because they both have the 2 arcs. Angle B and E, they both have 3 arcs. And C and E, they both have, or C and F, they both have that 1 arc. So we've identified the congruent angles. Next, we want to identify the corresponding sides and the scale factor. So it helps to identify the corresponding angles and sides if we draw arrows. And what I mean by that is, so right here, if I draw an arrow from A to B, and you can see here again I have those 2 arcs for angle A, the 3 arcs for angle B. Here I have the 2 arcs for angle D and the 3 arcs for angle E, and so my arrow would go from D to E. Alright, so those are my corresponding sides, and so I can set up a proportion AB over DE, and so AB is 12 and DE is 15. Let's reduce the fraction. That reduces to 4/5. They're both divisible by 3. Next, BC. So right here, we have the 3 arcs and 1 arc. So that corresponding side would be EF because E has the 3 arcs like B, and F has the 1 arc like C. So our proportion BC over EF, so make sure it's in the same position. So I'm putting my first side for that first triangle at the top and then a second triangle at the bottom. Alright, so BC over EF is 16 over 20. That also reduces to 4/5. If it did not reduce to the same ratio, you could just stop and say they're not similar. But since it is reducing to the same fraction, we have to do the third side as well. The only 2 sides to the left are AC and FD, or DF, sorry, because we're going from 1 arc to the 2 arcs. And so that would be 8 over 10. That reduces to 4/5. Alright, so the scale factor is 4/5, so 4 to 5, as we can see right here. They all reduce to 4 over 5. And then our similarity statement right here, triangle ABC is similar to triangle DF, and always make sure that you have the same angles and sides in the corresponding positions. So I would like for you to try this problem on your own. Again, it asks, are the polygons similar? If they are, write a similarity statement and give the scale factor. So keep in mind you want to identify pairs of congruent angles and identify corresponding sides and the scale factor. So go ahead and pause the video and try this example on your own. Alright, so first, check to see if you identify the angle pairs correctly or the congruent angles. Next, compare the ratios of the corresponding sides. And so as you can see right here, if you do JK over TU, you get 2 to 1. KL over UV, you get 3 to 2. So you really did not have to do all of the sides. So once they are different, or they don't reduce to the same thing, you could simply stop and say that since the corresponding sides are not proportional, these polygons are not similar. So if they're not similar, you cannot find the scale factor. Alright, so let's take a look at this example here. We have two similar triangles. It's a triangle within a triangle, and so we want to find a value of x. So the way we do that, we want to set up a proportion. So I'm going to write a fraction with the smallest angle or the smallest triangle to the largest triangle. So if we look at this side right here, side AB, alright, the smaller triangle AD has a length or that side of 20. Alright, and the larger triangle, alright, since AD is 20 and DB is 8, the length of AB is 28. So smaller to larger. Alright, and then the corresponding side to the smaller triangle. So the smaller triangle here would be 15. Alright, and then a larger triangle, side BC, would be 2x plus 3. Before I cross multiply, I am going to reduce this fraction. So this fraction reduces to 5 over 7. Both divisible by 4. Alright, so it's easier to reduce fractions because you're going to have those smaller numbers to deal with. And now I'm going to cross multiply. So 5 times 2x plus 3 is equal to 15 times 7. That leaves me with 10x plus 15, just using the distributive property. 15 times 7 is 105. Now I'm just left with that two-step equation. 10x equals 90. Divide by 10, so x is 9. Alright, and so make sure when you're finding a value, you set up those corresponding sides. And so I just did smaller triangle over larger triangle. You could have done larger over smaller as long as your corresponding sides are in the same position. Alright, so this is the last one I would like for you to try on your own. Again, you have a triangle within a triangle. But now for this one, you're asked to find the side YZ. So of course, after you find the value of x, you're simply just plugging in x to the expression for YZ. So go ahead and pause the video and try this example on your own. Alright, so here's the answer to example 7. You should have gotten x equals 13 and YZ equals 28. Of course, you're just going to plug it in right here. 2 times 13 plus 2 give you 26 plus 2. You could have set up your proportion a little differently than what I have here. I just have the smaller triangle right here to the larger triangle, but as long as you set up those corresponding sides correctly, you will get the same answer. So I hope you got this problem correct. Alright, so we've reached the end of our lesson. I want to thank you for learning with me. Some related videos are proving triangle similar and triangle proportionality theorem or the side splitter theorem. If you have not already, please like, comment, share, and subscribe. And again, I would like to thank you for learning with me.